Hello, my fellow plastic fanatics. Chris here from Scale Speed Garage. Wanted to bring you this video. This video is part of our brand new Scale Speed Garage Elite membership tier that we launched last month. We heard over and over from you guys that you were getting comfortable with 3D printing, really enjoying adding 3D printing into your scale auto modeling hobby, but that sort of the next frontier for you was growing into learning how to design your own parts in 3D CAD. And so we have taken that wish from our community, turned that into Scale Speed Garage Elite. In Scale Speed Garage Elite, members get 2 monthly live training sessions on using Fusion 360 for their CAD design, and we are starting from the very beginning, the very basics. If you can turn on your computer, we will get you started designing your own parts. So we do 2 monthly live sessions over Zoom. We take the recordings of all those sessions and we package those and put those in the website for Elite members to view at any time. If you miss the live training and want to catch up, if you want to go back and refresh your memory or just learn on your own time at your own pace, you can do that. Like I mentioned, we are starting from the very beginning, the very basics. And so I wanted to bring you this video. This is the first training session that we did, the very basics, where we take an in-depth look at Autodesk Fusion and we take a tour of it and kind of get familiar with the layout of the software, the location of the tools, how to navigate the software, and then take kind of a brief look at the tools. I wanted to bring you this introductory video here to YouTube for everybody to see. It will give you a taste of what we will be covering in Scale Speed Garage Elite in the Scale Speed Academy courses, the 3D training courses, and give you an idea there of what that looks like. But also, Scale Speed Garage Elite members don't only get access to the 3D training, they also get access to all of the great other features of Scale Speed Garage. So those are our monthly file downloads. That is 50 or more STL files every month that you can download and 3D print as many times as you like, as well as troubleshooting help, both with the 3D printing side of things as well as the 3D CAD side of things. And we also have hours of video tutorials on 3D printing and partner discounts from some of our partner vendors. And these are companies that we love, that we believe strongly in, that offer our community a great product at a great price with great service. We've partnered up with them to bring you discounts with them as well as a Scale Speed Garage member. And not to mention our fantastic community within Scale Speed Garage. This is an exclusive members community where we have a forum, we have kind of a social wall. It's like a little mini Facebook within the members area, and then our weekly shop talk Zoom hangouts. And this is another Zoom call that we do once a week where we just hang out and chat about anything and everything from modeling to real cars to just life in general. And it's truly a highlight of my week every week. So go ahead and check it out if you are interested in learning 3D design for your hobby. In Scale Speed Academy, our mission is not going to just be to teach you the 3D modeling software, but we are going to take all of the things that we have learned over our years of designing for scale model resin printing, all of the tips and tricks that go along with that, all of the kind of unique things that we have to consider when we're designing for printing in scale, and we're giving you that information as well to help you design parts that are not only beautiful and detailed, but also parts that have great printability, parts that are easy to build and assemble in detail once they are printed. And you can take a test drive of any of the Scale Speed Garage membership tiers, 2 weeks for just $1. Get in, check it out, see what you think. And you can find that at scalespeedgarage.com. And without further ado, let's jump into our Scale Speed Academy Session 1. This is the introduction to Autodesk Fusion.
Before this gets started, I just have one quick question for you, Chris. Yeah. So like the little video you did for this course where you're, building the engine and stuff, do you have like a set of like blueprints or measurements that you're going by with that? Or when you do something like that?
Yeah, there's, so it kind of depends on what the item is. So for a lot of times when I do engines, and I definitely did the Cummins engine that you saw in the video, I did those, I kind of start with specifications that you can find online, right? So we know that, I can go online and I can find the bore and the stroke of an engine. I can find the piston height of the engine, the deck height. And so when I'm going to do an engine, I'll start with the geometry first. And so I always put like the front face of the engine block on the front plane.
Right.
And I center the crankshaft center line along that axis that runs through, perpendicular to that face. And so then everything from there, I just drive off of the that sort of origin point and that crankshaft center line. So from there, I can create construction planes, construction lines, things like that to give me the location of everything. Okay. And then from there, what I'll usually do is I'll create a construction plane at the top of the cylinder deck. Whether that's, if that's an inline engine, then that's going to be a plane that's flat, right? If it's a V engine, it's probably going to be a plane that's at 45 degrees, not always, but usually.
Right.
And then what I'll do is I will create my, one of the other specifications I'll find when I'm doing my research is, okay, what's the bore spacing of the cylinders? And then I'll create a sketch on that cylinder deck plane and lay out where my cylinders are going to go. So, if it's an engine with a 4-inch bore, I will, create a set of circles that are 4 scale inches in diameter, spaced at whatever that cylinder spacing is, that bore spacing is. And then from there, typically the way I start kind of further defining that surface, and I usually work top down from the cylinder decks, is then I'll go out online and I'll find a good flat straight on image of a head gasket. Because that pretty much gives me the shape of the top of the cylinder deck and the bottom of the cylinder head. And I'll bring that in as what we call a canvas. And this is all stuff that we'll kind of go through over successive courses, but I'll bring that in as what we call a canvas in Fusion. And I bring the canvas in and then I resize it, scale it, and move it to where it needs to be so that that image of the head gasket is scaled correctly and it's sitting properly on the cylinder bores. And then from there, I can kind of start building the tops of the cylinder decks.
That makes sense.
Yeah. So that's kind of, kind of a long way of answering, it's a little bit of everything from having a physical item in my hand that I measure, whether that's a kit part that I'm
Right.
going off of, or whether it's a full scale one-to-one car part, physically measuring a physical item, or using known dimensions and measurements and reference images. So there are a lot of ways that we can go about it. And so just to kind of give you an idea on the structure of this course, we are going to start from the very beginning and assume that, the viewer has zero knowledge in any of this. And we're going to first kind of talk about some of the terminology that we'll use a lot. We will take a tour of the Fusion environment, and we'll kind of start looking at some tools. And I have a hunch that's about all we're going to get to tonight. And then in the next course, on the second Monday in August, we'll kind of start diving into doing some more design, actual design. So just real quickly then, I'll kind of describe what Fusion is and what it is not. And then we'll kind of start talking about some general 3D principles. So Autodesk Fusion is what they call the main environment in Autodesk Fusion, the one that we're going to focus most heavily on, is what they call a parametric solid modeler. And so I'll break that down. The word modeler, that we all know that, but that word parametric means that everything's done around parameters. So unlike some other 3D software where you're just kind of almost more like a sculptor, working in clay and freehanding stuff, Fusion works around math and numbers, dimensions, things like that. And those are the parameters that we talk about when we talk about parametric modeling. Now, this has some benefits, also has some drawbacks. The drawbacks are, certain other softwares are really good at doing sort of more free form things. So there are other softwares out there that are better suited to doing things like full car bodies or body kit parts, things that have a lot of sort of complex organic shapes. Fusion isn't necessarily the best tool for that. And I would say another drawback is the parametric nature of it means that there's more of a learning curve. Some of the other 3D softwares are very sort of like, almost like you have some clay in your hands, right? And you can just kind of go in, create a shape, manipulate it how you want. There's some of that ability in Fusion, but it's really not the way the software is designed, and probably really not the way you're going to get the best results. Now, the benefits of parametric modeling is that you end up, as you're designing, you end up with what's called a design timeline. And if you are taking the steps correctly, what this means is that everything in your timeline should be editable. So if let's say you get a couple hours into a design and you realize that, oh, one of my initial measurements should have been this instead of that, you can go back and change that at any time, and the rest of the design will update. So there's a lot of power there in having that editability, which a lot of the other more sort of free form design softwares I've seen, you don't necessarily have that. And to go back in the timeline and make a change like that can be pretty tricky, and it can end up causing problems down throughout your design timeline. And so that's one thing that we'll be big on focusing here, is not only what do the tools do and how do we use them, but we'll also look at the process of starting with a design and starting with the design in your head and kind of thinking steps ahead so that we can build a really robust model with a very clean timeline that will allow you to make changes and adapt things as needed along the way. Another very cool thing that we'll get to later on in the course, but it's worth mentioning now, is another benefit of parametric modeling is we can actually create parameters. So for example, when I'm designing a wheel, I have a set of standard parameters that I pull up. I pull up a tool called the parameters table, and I create a chart basically of all the different parameters for that wheel. So we're going to have overall wheel diameter, overall wheel width, maybe things like offset, what the number of lugs are on the wheel, what the bolt pattern spacing is on those lugs, all sorts of things we can put into this parameters table. And then when we're building a design, instead of giving something a definite measurement like 15 inches, we instead say, for this dimension, go reference this in the parameter table. And that gives us that adaptability. So I can go back in and change that in the parameters table, and it will change every instance of that dimension throughout our design without us having to hunt through the timeline and change it in multiple places. And a newer tool that they just added to Fusion is called the configurations tool, which takes those parameters one step further. So if I'm designing a wheel, now I have my parameters table that has my diameter and my width and my lug count and all that. I can then also create a configurations table where I say, okay, I'm going to want a 15 by 7 wheel. So I'm going to give it a name. This configuration is 15 by 7. This is the diameter for that wheel. This is the width for that wheel. I'm going to want a 16 by 9. So this is the diameter for that version, and this is the width for that version, etc. And then I create that configuration table, and then I end up with a little drop-down menu over here where I can just quickly switch between versions. So when I'm doing wheels, for example, that's how I'll do it, right? Like we're big on the details here. And so, I never take a 15-inch wheel and scale it up to 19 inches and just give you that, right? Because then the bolt pattern is way out of proportion. It doesn't look right. So instead, we create a configurations table like that where I have control over all of that stuff, so I can create multiple very accurate versions of a part with a lot less work. So that's another fantastic element to parametric modeling. And then lastly is just kind of, the other points have touched on it, but parametric modeling just is a very accurate way to do things. Like we can design model car parts for 3D printing here, which, they don't have to be crucially exact on dimensions for them to work. We could also design space shuttle parts in Fusion that need to be accurate to within, 10,000ths of an inch in the same software. And so it really gives us a lot of control as well. So I'm going to switch over now to the Fusion environment. So this is what it looks like when you open Fusion. So yeah, this is the data panel here. So this is what I was talking about. This grid icon here shows and hides the data panel. If you hit home, it brings you to your top level home page for all of your designs. Our Scale Speed Academy folder is down here. If you want to create like your own personal project where you're going to keep all your personal stuff, you can certainly do that. So we could call this like Greg's project. But as we see here, so I open Scale Speed Academy. There's the folder I just created, obviously new folder. And then we can right click to rename or open or delete things. You can also just double click on items to open them. And then you have this navigation here. So you can go up and down levels in the folders pretty easily. This way, this is the globe icon that I mentioned that pulls up that web-based way to view a project. So like I said, I will get you all added to this project. I'm going to collapse the data panel here. And now we're going to look first, starting at the top. We'll start at the very top. So we do have our file file menu here, so we can create a new design by clicking on new design. We won't touch anything with electronics. You guys may not even have that in the hobbyist version, I don't recall. Drawings, this one's a little tricky. People think, oh, well, I'm starting with a sketch for a design, I want a drawing. That's not what this is. The drawing environment is for creating like blueprints or plans of an item. So we're going to largely skip the drawing things. So really you'd be looking at new design, open, upload, save. We're not going to do any exporting from the file menu. That does a cloud-based export, and if we're looking to export STL files, there's a much better way that I will show you later on. Next, we just have a button for save, but all of the, we'll just call this test 1. All of your normal keyboard commands are going to work, so like Control S for save, Control N for new. All of those work in here as well as they might in any other software you use. Next to those, they're grayed out right now because we haven't done anything, but we have an undo and a redo button. And this is just for, like any other software, undoing what you just did or redoing what you just undid. And then this home button just kind of brings you to an overall home where you can look at all your recent files or whatever else. But we're just going to come back into our design here. And so the rest of the tabs up here are just your design. So if we create another design, that shows up here. So this is another way to create a new design, is to just click this plus button up here in the tabs. And then we don't need to worry about extensions. Job status is just if you're running something like an export or a render, you can check on its status up here. It also tells us if we're working online. Fusion is a web-based, cloud-based software, so you do really need to be online to use it. You can work offline, but you just have to then save stuff locally. We've got a notification center up here. This is usually when they give you updates and things, they'll put a little notification up there. There is a great help menu. So you can show an entire learning panel. There's also self-paced learning, documentation, stuff like that. So a lot of help here. And then your account is up here. So your Autodesk account would be things like billing and your login information. Preferences we'll take a quick look at. A lot of the stuff we do for, for what we do, we're going to kind of scratch the surface on the capabilities of Fusion a lot. But some things that are good to look at in the main preferences menu here, so was it Lloyd, you were saying that Fusion didn't like your graphics driver?
Yeah, it's telling me that my graphics driver may not be
okay.
up to the task.
So you could pull this up. There's a couple of things you could do. You could update the graphics driver on your computer. If that's not getting you to where you want to be, you could also come up and see if you can select a different driver, like a different version of DirectX, or run OpenGL. And automatic recovery backup interval. This is a good one. I like to keep this set at 5 minutes. This creates an automatic save every 5 minutes in case Fusion crashes. You don't lose a ton of work if you've forgotten to save. Everybody make sure, just to keep us all on the same page, everybody make sure that your default modeling orientation is Z up. And what this does is this is just defining what direction our origin axes point. And so just like our 3D printers, right, where the Z-axis is the vertical axis, let's, make sure that you're set to Z up here as well. And that'll just keep us all on the same page. If you're having issues with the graphics being a little choppy, you can uncheck this box that says animate view transitions. And what this does is anytime we change the view, like change what angle we're viewing our design from, if we have this checked, it'll kind of animate that rotation, but that can kind of bog some systems down. So if you're having choppy performance, you can just uncheck that. I always like to keep show tooltips checked. Tooltips we'll talk about a little bit later on. Command prompt I like to keep checked as well. All of these really I keep checked. For pan, zoom, and orbit shortcuts, these are how we are going to interact with our model in 3D, how we're going to navigate around that. You can set this up if if you have some experience in, say, Alias or SolidWorks or Tinkercad, you can set this up to use the same shortcuts for navigating that you're already used to, or you can leave it as is and just learn the Fusion way of navigating here. That's really going to be the main thing for us. We are, one other thing, let's go down to default units, to the design. Make sure this is, make sure you have millimeters selected here for your default units. Now, I think all of us except for Jamie are not probably necessarily used to millimeters as a unit that we interact with a lot. But there's a very good reason why.
Most of the model building and everything anyways I do is all in millimeters anyways, so
Sure.
I'm good with it all.
So the reason that millimeters are great is because when we design in 1/25th scale, 1 inch in the real world equals basically 1 millimeter at 1/25th scale. It's actually like 1.016, but for the purposes of what we do, really we can get away with 1 inch equals 1 millimeter. And so it just really makes things easy. And that brings up the question of, should we design in full scale and then scale that down by a factor of 25 to get it into the scale we want? Or should we design in scale? I am always a proponent of designing in scale, because as we do this, as you get more comfortable with this, you're going to start learning some general guidelines about what size features are printable. And the problem is, if you design something, you could design something perfect that's an exact match in 1:1 scale, and then you scale it down by 25 and you have stuff that's tiny, like too small to print. And so there will be times where we will actually intentionally design a little bit out of scale or a little bit out of proportion in order to make something printable. And that's kind of where, there's a little bit of engineering here, but also a little bit of art. And we bring those together by kind of developing that sense of what will work in printed form. And you can always check also if your document is in millimeters or not. And if it's not, you can also change that here under document settings. You just click this little pencil icon and you can select whatever unit you like. Any questions so far? Okay, perfect. I did pull up the chat also, guys, so I have it here. So if there's something, you know, if you have a question and I'm not stopping to ask if you have a question, you can always also just drop in the chat like, hey, I have a question. All right, so now we'll move down a little bit in our toolbar here, and we'll take a look at the different environments that, the different environments that Fusion has. So the one we will work in almost all of the time is solid, the solid environment. So we are creating solid objects here. There is also a surface environment. This is, I like to say this is kind of the difference between building a model out of a plastic model kit versus one of those like paper models that you may have seen where you like print a bunch of stuff on printer paper and then you cut it out and then you fold it and you glue it to create a model. That would be like surface modeling. We're still defining the shape of an object, but it doesn't have any like solidness to it. It doesn't have any substance. It's just the outer shell. This will come in handy a lot, and there are actually times where we will start something as a surface in a surface environment and then turn that into a solid object, or use the surfaces that we create to run other operations on a solid object that we have. And so I would explain that kind of like, if we have a solid object and we want to say cut it in sort of a complex way, like you might do on say a water jet cutter, you have a piece of metal and you want to, cut some sort of complex shape out of it. We might use a surface or a collection of surfaces to do that cutting operation. The next environment is mesh. This one is actually part and parcel to what we do, but we're not going to use it a whole lot. Mesh 3D files are things like STL files or OBJ files, 3DMF files, and they are considered solid objects, but they're solid objects that are defined by surfaces. And so if you've ever looked at an STL file really up close in your slicer or in, say, a program like Mesh Mixer or Blender, what you notice is that the faces are all collections of triangles. And so that's an example of a mesh. So Fusion does have a mesh environment, but it's not the best tool to use for a lot of mesh stuff. So we'll probably only kind of hit this environment incidentally. Same with sheet metal. Sheet metal's not really going to be relevant to what we're doing. The plastic environment could be, however, a lot of the tools in the plastic environment are only available through purchasing like extension packs or add-ons. And so we really won't touch the plastics environment at all. Manage is not something we need to worry about. This is like if you're managing a team of designers, you can maintain, version control and markups and things like that. That has probably zero relevance to us here. The utilities menu, however, does have a couple things that we may use, specifically what we call a section analysis. And I'll just give you I'll just create a quick little shape here using a primitive. And if I'm going to create a work plane real quick to kind of show you this as well. So we'll create a plane that runs diagonally through this cube. And so what this section analysis is it allows us to do a cutaway view. A section view is just another term for a cutaway view. So if we're working on something complex and we want to be able to see inside of it, we can create this cutaway view that we can toggle on and off using the section analysis here. So I would click section analysis and then choose this construction plane that I just made to create the section. And now you see I can go in and look at the inside of that object. Now to turn that on and off, I can just go over to my analysis folder here in my browser and turn that off. So we'll click back over to the solid menu here. I'm going to save this toolbar for a little bit later on in this course because this is where all of the actual tools are, but I want to show you kind of everything else first. So we'll now move down to the left-hand side here. And so we see we have this browser. We can collapse this if it's in our way. Especially helpful if you're working on like a laptop screen and you don't have as big of a screen to work with. You don't want this taking up valuable real estate all the time. You can just collapse it and then expand it when you need. But when we first start the document, we can see we really don't have much of anything in here. In fact, this analysis wouldn't even be in here also. All we have are document settings, named views, and then origin. Now the origin, like I was talking about when we were kind of talking about engines, that's our sort of home base for the design. And so we have 3 planes that you can see. And if we look up here to our view cube, we see that, you know, we have this Z axis. We see the letter Z here in blue, and that corresponds to this blue axis here. And then we have the X axis in red and the Y axis in green. And so this plane right here would be the ZY plane because it's the plane that runs through the Z axis and the Y axis, just like this one would be the XY axis, or sorry, the XY plane, and this one would be the XZ plane. Typically, we will just, for our purposes, we'll call them front plane, right plane, bottom plane, things like that. But I mentioned the view cube up here. This is a very quick way to navigate. So if we want to look at the right side of something, we can just click on right. And that brings us into a straight on 90-degree straight ahead view of the right side of our design. We can use the arrows to navigate. So, you know, if I come over here, now we're looking at the front, click it again, now we're looking at the left. If I click this bottom one, now we're looking at the bottom, and so on. We can also rotate 90 degrees using these sort of curved arrows here. We can also click the home button to bring us back to whatever our home view is. And you can also see here, we don't just have the right, front, top, you know, we don't just have the flat sides of the view cube. We can look from an angle as well, from 45-degree angles. So I could look flat on, you know, and see kind of the front and right of an item. I could click on the corner, and that brings us to this kind of top-down angle view. So this is one way to navigate through the workspace here. But that's what the origin is. Usually I leave the origin on, but if you want it off, you can also just click the eyeball icon there, and you can expand it. You can turn on and off individual parts of the origin too. So I could turn off, say, 2 of the planes, but leave 1 plane visible, etc. I could turn off an axis. And then this one here, this white point that we see in the middle where all 3 axes come together, that's just our 0 point. That's our home point. And so, you know, I kind of describe it as like, you know, if we put this model in an acrylic display case, right? That's kind of what our view cube is. I could say, look at this side, and it would turn. You know, look at the top, and it would turn. And so those are just what we call orthographic views of an object. And so that's one way to navigate. We also have some navigation tools down here on the bottom. So we have the orbit tool, and it may be a little hard to see, but when you click on the orbit tool, it brings up this sort of orbit handle on the screen, and you can select different parts of it, click and drag to rotate things a certain way. So maybe I'll bring back my cube again here just for ease of explanation here. So yeah, if I come around this outer circle, then I'm rotating it in the direction of that outer circle. But then you see I also have these handles here to the top and bottom and to the left and right. And so I can use those to rotate as well. And this is what we call a constrained orbit. So I'm only able to orbit in directions relating to our axes. But I can also come down here and instead click and hold and go to free orbit. And now it allows me to just orbit in any direction I want, like I'm holding the object in my hand and can rotate it all around. Use that hand raise function if you don't have a mouse with a scroll wheel. Anybody just have like a 2-button mouse that doesn't have a scroll wheel?
No, got a wheel.
Okay. I think, I don't know, I don't even know if they sell mice without scroll wheels anymore, but we can also use our scroll wheel to navigate. So for zooming in, you're going to pull that scroll wheel back to you. You can change this behavior. You can flip-flop this in the preferences menu we looked at, but just for the sake of simplicity, we'll keep it as is. To zoom out, you scroll like you're scrolling up a web page. To zoom in, you scroll like you're scrolling down the web page. And the way I always keep this straight in my mind is if I'm on a web page and I'm reading and I want more information, I scroll down. If I'm looking at the object and I want to zoom in and get more information, I scroll down. But the scroll wheel doesn't stop there. Most scroll wheels you can also click on. And so if you push your scroll wheel down and hold it, now we activated the pan tool. So I can pan whatever current view I have, left, right, up, down, really any direction. But you notice I'm not rotating the object, I'm just panning my view of the object. And then finally, if we hold down the shift key on our keyboard and click and hold the scroll wheel down, now I get a free orbit tool.
Okay.
And so these are things that will save you quite a lot of time. It doesn't seem like that much more effort to come down and click on your orbit tool, but I promise you, as you get better at this, as you get faster at this, you will find that it saves you a lot of time to kind of learn these shortcuts. So my intention here is that I'm going to, when I teach you a new tool, I'm going to show you where the button is, where the physical icon is on the screen that you can click and open the tool that way. But we'll also talk about keyboard shortcuts. Some of them, I've created shortcuts where there weren't shortcuts. And so we may talk about that as well. I can show you how to create new keyboard shortcuts for tools that you use a lot. But again, using things like pressing down the scroll wheel and dragging for pan, holding shift and pressing down the scroll wheel for an orbit, and zooming in and out using your scroll wheel do save you a lot of time. We also have those tools down here on our view menu at the bottom. So we have the pan tool. I can click on that, move things around. We have a zoom tool. If I activate that, you see it gives us just this up down arrow thing, and I can then left click with my mouse and zoom in or out. We also have a zoom window where I can click on that and say zoom in just there. And then this one here that kind of looks like a little open book, this is the look at tool. So I could click look at and then click a face, and it brings me into an orthographic straight on view of that face. Next, we have some display settings, and we'll kind of show you some of these. I'm going to go into kind of an orthographic corner view just to show you what these settings do here on our cube. So if we click the display settings, the first thing we have is visual style. So this dictates how we see the object. And right now, typically I like to work in this shaded with visible edges only mode, but I'll show you if we go over to just shaded, you see it took away the black lines on our edges. This can give you kind of a more natural view of an object, but you do lose that information of the boundaries between faces. We could go to shaded with hidden edges, and so now you see that brought back the edges that are visible in front in black, but then in black dotted lines, it also gives us the hidden edges. So these are edges that exist, but we can't see them currently from this view.
So that's like looking through the block.
Yeah, it kind of gives you X-ray vision.
Okay.
Yep. Shaded with visible edges only, that's that's the one I was showing you. That's how I normally prefer to work. Everybody's style is going to be different. If you find that you like one of the other styles, totally fine. The next one is what's called wireframe. So it takes away all of the shading and almost brings us back to a kind of an old school AutoCAD type look, where all we see are the edges between faces, and we have wireframe with hidden edges. That changes those edges to dotted lines, indicating that they're on the other side of the object. Or wireframe with visible edges only, which is probably the least confusing way to use wireframe. But again, I generally default to shaded with visible edges only. The next thing in the display settings menu is our environment. And so we can actually change what our screen looks like. So if you prefer a dark mode, which I definitely prefer dark mode like on my phone, but I personally don't love designing on anything other than a white background, but we do have some other choices here as well. The photo booth is the white one. The blue is, that's maybe not the one I was thinking of. Infinity pool is kind of another white one, but then it turns gray as you rotate. So that can help give you a sense of location. If you're finding yourself getting lost and kind of wondering, wait, how do I have this rotated? You might try the infinity pool one, because it kind of tells us, oh, now I'm looking up from the bottom. And the final one is River Rubicon, another dark setting there. Again, that's personal preference. Really, whichever you feel most comfortable with, you can use. I like the photo booth. Next are effects. So we can have it turn on a ground plane, which will give us shadows. I just find those a little bit confusing and distracting. Object shadow we can leave on if you want. That would, if I had another block behind this one, then this block might cast a little bit of a shadow on that block. Environment dome, I don't think I've ever really even played with that. I just sort of leave it on its default on. Anti-aliasing would be one if you want smoother lines when looking at things on an angle. You can turn on anti-aliasing, just with the caveat that anti-aliasing will require more RAM, more processor power. So if you have that turned on and things are a little choppy, you can just turn it off. Ambient occlusion has to do with how the computer displays items that are like transparent or translucent. Not really necessary to go into for what we do here. Below that in the display settings is object visibility. Now this is really useful if you're working on a design and like we have our axes and our planes and our origin point here. If I want to quickly turn all that off, I can turn off origin planes, origin axes, origin points, etc. If I scoot back forward here to where I have this work plane again, if I wanted to turn off all of my construction planes, my work planes, I could do that here. Axes and things like that as well. Sketches, as we'll get into, I can turn off all sketches at once by clicking this. And I can also turn on and off all work features. So if you want to see what your object looks like without any of the other stuff distracting you, you can just quickly come and uncheck all work features and it turns all of that off. Next thing we have is the camera. So I mentioned the term orthographic before, and that's just the idea of seeing things from straight on views without any perspective, right? So when we look out in the world, naturally we see perspective. And so that is one option here. So if we come back to a sort of a corner view of this block, I'm going to turn off that plane real quick. We'll do that with work features. If we look at this cube, it doesn't look quite right to us, right? It doesn't look natural. And that's because if we were looking at this thing in the real world, we would have a little bit of perspective going on, which means that this line here wouldn't be perfectly parallel to this line here. It would in fact sort of point at an inward angle so that eventually those lines would connect. If you think back to, maybe you had a drawing class in school and you learned how to draw perspective, right? And you create a vanishing point and then all lines that are perpendicular to your view all converge towards that vanishing point. That's the same kind of thing here. So if you feel like it's more natural to look at this in perspective with how you would normally look at it, you can come to the camera tool and choose perspective. And now we see that looks a little bit more natural. That looks like what a cube would actually look like in the real world. But we use orthographic because it's geometrically more correct for designing, right? And it gives us a little bit more information about, parallel and perpendicular planes, things like that. Typically, I design in orthographic, but if I'm going to do a screenshot, for example, like if I'm going to do a screenshot of a design I'm working on and I'm going to say, I'm going to post it to Facebook, usually I'll go in and switch that over to perspective just so it has a little bit more natural of a look. Ground plane offset doesn't really matter for what we are doing here, so we'll just kind of skip that. Grids and snaps. So we can turn on a grid if we want, to where, each of the divisions in this grid is 1 millimeter, and then it's broken up into larger subdivisions of 5 millimeters. I've never really seen the point in using this, because again, we're not, you might use grid paper or graph paper if you're drawing something by hand and you kind of want to draw straight lines with even measurements. But for us, we're going to define the measurements in everything that we're designing anyways. So I've never really seen the purpose of using the grid. Of course, you can turn it on if you prefer it, but I've always just found it kind of gets in the way, so I usually have it turned off. In fact, always have it turned off. I don't ever design with that in place. You could, if you have the grid on, you can also turn on snap to grid, which means that if you're creating a sketch or doing some other things, you'll snap to the points on the grid, which is great if you want to create something that's exactly 5 millimeters. But if you want to create something that's 5.3 millimeters, for example, then you're kind of fighting the snap. So I leave that off as well. Incremental move, this is, we'll kind of look at this in the context of using some tools, so I won't cover it right here. The last menu we have here on our view menu is our viewports, and so this is handy. If any of you guys saw, like Nick was mentioning, the time-lapse video of us designing the Cummins engine, you saw how we had two views of it. We had one view, from like the right side of the engine, one view from the left side of the engine. We did that using viewports. So we can come here and click multiple views. And then this gives us windows that we can click and drag and see all sides of an image or all sides of an object at once.
Look at that. That's cool.
Yeah. So this definitely can be a useful tool. And then what happens is you click over to each viewport and you get the view cube pops up in there. So if I wanted this instead to be another angled view, I could just click on a corner on my view cube in here. I can zoom in, zoom out, click over to this side, zoom in here, and it doesn't zoom in on all the rest of them. So this can be a helpful tool. In general, though, I'm going to say I almost never, I'm going to switch back to single view. I almost never use that unless it's kind of for display purposes, because I find the navigation tools just so easy to use. Questions at this point?
Okay, cool.
Awesome. So we have covered, so we talked about the browser, but now that we have a little bit more going on, I'll come back over to the browser. You see, again, when we first open a new document, we really don't have a lot of stuff in the browser here. But once I created that cube, now all of a sudden you see I have another folder that pops up here, and this is bodies. So I can expand this, and this cube is body 1. Now the cool thing about this is that all of these are editable, so I can click on this again, select it, click on the name again, and I can change the name of the object. So once you're working on something that has a bunch of different bodies in it, you can keep them straight by naming them some sort of descriptive name. So we call that cube. If I came in and created another, let's say I created a Taurus, not a Ford Taurus. Here, created a new body. Now you see I have body 2 that shows up in my bodies folder in the browser, and I could name this Taurus. And so on and so forth. Now, I'm going to skip ahead again here, bring back, I'm going to turn on all work features. There we go. Bring back this diagonal plane that I made. And now you see I have another folder down here in the browser, and that's construction. So construction features are anything that we use to help define the geography or the geometry or the placement of anything. Those are considered construction features, and we'll talk about those extensively. So any planes or axes or points that we create, they'll all show up here. So I could click on this, click it again, and rename this like diagonal cut plane. Hit enter. And now I know, you know, when I get to the point in the design where I have 30 work planes, I don't have to like click on each one to see which one it is. I can just come and say, oh, I need my diagonal cut plane on. Boom, turn it on. So you've probably seen me now coming down here to the very bottom and kind of manipulating things here. This is that design timeline that I was telling you about. And so when we create a design, every step of the process will be recorded down here. And we can click and drag on this little, it looks sort of like a funnel with a really long funnel. This is the, what do they call it? The design, the history marker. So we can move the history marker throughout the design to take us back to a certain place in our design timeline. We can also right click on it or right click anywhere in the timeline and say roll our history marker here. So again, I'm right clicking on the feature and moving the history marker there. And so again, this is one of the very powerful things about parametric modeling is I can come in anywhere in the design timeline and change something that I've already done just by either right clicking on it and going to edit feature or by double clicking on it. So if I double click on this cube or this box, it pulls back up the feature menu. So let's say, you know, this is currently 38 millimeters long. Let's say I actually wanted that to be 88 millimeters long. I just change the dimension, hit OK. When we created the torus, we created it as a new body, but if I instead meant to cut that toroidal shape out of our box here, I could just double click on the torus, change the operation from new body to cut. And then you see, I'm going to turn off that work plane. Now you see we have that sort of donut shaped cut in the object. Or maybe I messed it up again and I actually meant to just join those two together, come back in and change that to join. I can change the size of it here as well. So I could make the diameter 45, and that's the diameter of the cross section. And I could say make the inner diameter 95 and hit OK. And so that covers, that's kind of a very quick introduction to 3 of the 4 sort of operations we can do. New body, cut, join. There is, however, a 4th operation that sometimes comes in handy. So if I double click on our torus again here, if I change this to intersect, what do you guys think it'll do if I change the operation to intersect?
Going to put them together equally, I would think.
No, it'll remove everything but the parts that match.
Exactly. Yep, Lloyd's got it. So it will only keep the areas where these 2 shapes overlap, and it will look like that.
Oh, all right.
Yeah. So that one is useful. It's definitely the least used of the 4, at least for what we do. But there are times where it comes in handy, and I will, as I kind of plan out our future courses and what we're going to design, I will definitely look for ways that we can incorporate a, an intersect operation so you guys can see that.
Can you manipulate? So when you're doing that, can you manipulate it to get it, like say you wanted a little bit more symmetrical? Is there a way you can manipulate all that stuff to do that before you, or while you're looking at the intersect?
Absolutely. So let me go back and edit this first to be a new body. And I'm going to show you another thing here. As we mentioned in the browser, we have the cube, and then we have body 3, which is our torus. Now, if I instead did a join operation, now you see we only have one body here, and it's still named cube, so we would maybe go in and rename it, boxy donut or something. But yes, if they are two separate bodies, then we have a few ways that we could make this symmetrical, and we'll look at some of these more in depth, but I'll give you kind of a sneak peek of things to come. One way that I can think of to do this would be to create a midplane between the two end faces of our box here. So I select the midplane tool, I select one end of the box and then the other end of the box, and then it gives me a plane that is perfectly in the middle of those two. Now again, keep in mind that's parametric, so if I came back and edited the box again and I made that 1,000 millimeters long, that midplane would automatically adjust to still be perfectly in the middle of those two faces. So now I have a midplane here, and let's see if this will work. We don't often work with toruses, but let's see if an align tool will work. Can I just align this object? So when you pull up the align tool, you see you have a from and a to. So we're going to select the object we're moving from a place first, and then select the object we're moving it to. Now that did kind of the opposite of what we wanted to do, and flip doesn't work. Let's try that again. Okay. So if we kind of hover over the torus, we see that it's giving us this little, right in the center of the torus, it's giving us this little, sort of looks like a square with a circle inside of it. And because that square is flat, what that tells me is that it's going to mate that flat to whatever I select in the second step. So that's why when I select the torus first, now if I select this plane, it's going to flip that up at a 90-degree angle to make those two flat together. So there's another way we can go about this, which is just going to involve another step. But I can, now that I've created my midplane, now what I can do is create, let's see here, we would do axis through two planes. And so then I will select my midplane first, and then this front face of the box, because it is a flat face, that also constitutes a plane. So we will select that one as the second plane, and now we get a construction axis that runs where those two planes intersect. And now I bet what we can do is align and select this first, and then the axis. Yep. And boom, it just snapped. Let me show you again here.
Yeah.
So it's going to snap the very center point of that align to that axis. So, and I guess while we're working with primitives, we can look at some of these other tools. So the align tool is one if you want to in a very geometric and constrained way, move something from one place to another. Typically it's, when you're using the align tool, you're moving something in relation to something else or placing it in relation to something else. But we can also do free-form move operations or still fairly controlled move operations, just absolute moves rather than relative moves. So instead of moving it relative to the middle of the box, we can move it in absolute units. So if I click the move tool, and some of you may not have this right up in your tool menu, you may have to click the drop down for modify and then grab it here. But if I select this body with the move tool open, this first option is called free move. And this is sort of a very free form way of doing things. So you see it gives us this big old kind of complicated handle here, but I'll show you what each of these is. So the arrows are pretty self-explanatory, right? Move in the direction of this arrow, move in the direction of this arrow, move in the direction of that arrow. The rotate handles may also be pretty self-explanatory, so I can rotate around my various axes. But then these little sort of planes here, these little squares, this is like a pan move. So if I grab this one, let me think of how to show this well. I know how to show this well. We'll go back to viewports. Okay. Here we go. And we'll zoom out a little bit. And okay, so we're going to do all of our manipulating here. So I am looking in this viewport, I'm looking directly at the front. Oop, I was looking directly at the front. There we go. So if I click on the plane that is parallel to the view I'm looking at, meaning it just appears as an actual square, then I can move this up or down, left or right, but only up, down, left, and right relative to the view I'm in now. So you see, if we watch the lower left corner, it's not moving, let's see, it's moving back and forth across the length of the box, but it's not moving forward or backwards away from the box. And if I rotate my view up here, I'll use the view cube, come to the right. Now you see it feels like I'm moving freely, but if we watch that lower left quadrant again, you can see it's not moving side to side along the box. It's only moving forward or backward along the box. So that is our free move tool. Like I said, it's kind of the most willy-nilly or kind of loosey-goosey move tool that we have. Now, we don't have to be all loosey-goosey with it though either. I'm gonna bring us back to a little bit simpler of a view. And I am also going to, well, we can leave the align as it is. I'm going to rotate up here, pull back up my move tool. And so I will move the torus again. Now, instead of using the handles to just click and drag, I can also get more accurate and precise with it. I'm going to resize this window so we can see all of it. So if I want to move this torus backwards along the y-axis, again, that would be the one going back this way. If I want to move that 5 millimeters, I can just click on that arrow and type 5, and it'll move that. Now let's say I wanted to move it another 3 upward in the z-axis. Click on that handle, type 3. If I want to rotate it, say 40 degrees, I click on, you know, whichever handle for the direction that I want to rotate it, and then type 40. And so on and so on. So that is the first of our move tools, the free move. We also have what's called translate, and these are cumulative. So any changes that I make, if I have the free tool, the free move tool open and I make changes, if I click over to translate, it doesn't undo those changes I made. It starts from the, you know, where I left off. Translate is essentially just up, down, left, right. That's it. I get 3 arrow handles. I can move up, down, left, right, but I can't pan the object around. I can't rotate, etc. And so that's translate. The rotate tool, now you see I don't have any handles because it's missing some information here. So we already have the object selected that we want to move, this torus or this donut shape. But now you see in blue it has axis selected. And so we have to tell it what axis we're going to rotate this part around. And so I'm for ease of use, I'm just going to grab this construction axis we made. And you see when I select that, now I have a rotate handle. So I could move this using the handle. And you do notice as well, when I'm doing this, it's sort of clicking or snapping to 5-degree increments. If I zoomed way in, now it'll probably snap to, no, angle is still snapping to 5-degree increments. Okay. If you zoom way in and you're moving something, it will make the snap dimension smaller. So if I'm moving something left to right, out here, zoomed way out, you see I'm at 0. I move it and it's snapping in increments of 10, 20, 30, 40, 50. If I zoom in a little bit, now it's snapping in increments of 5. If I zoom in further, now we're in increments of 1 millimeter. And if I zoom in even further, it'll keep going smaller. So now we're at like 0.1, 0.2, 0.3 millimeters. But moving back to the rotate tool, again, I tell it what axis I want to rotate the object around. I can either do that by hand, or I could say, you know, let's rotate this negative 37.3 degrees. Then we also have point to point and point to position. I don't use these a ton. We'll look at those maybe a little bit more as they come up in specific use cases. But you will notice, I do want to just call out one other thing here, is at the bottom of all of these move options, we have this box where we can check create copy. This comes in handy quite a lot. So if I need 2 of these donuts, why make a second one when I can, you know, why go through the steps of making a second one if I know this one's going to be just the same? I can just check that create a copy box, and now my move tool just turned into a copy tool. Now, I will say if we needed, say, 6 of these donuts all going off in, you know, in this direction, I wouldn't recommend using the copy tool. We would use a pattern instead. But for onesies, twosies, things like that, can be a really great option. And so we looked at joining, cutting, and intersecting operations when we're creating a body. But next I'll show you how we can do that after the fact as well. But first I want to pause and see if anybody has any questions, anything that you would like shown a different way or explained differently.
This kind of seems a lot like that what do they call that? The Tinkercad, except it's got different ways of doing it.
Yeah, Tinkercad is an Autodesk product, and so they definitely share a lot of family lineage. And what we're doing so far really is a very sort of Tinkercad way of doing things. What we've been doing so far is using this section here of the Create menu, which is called Primitives. It doesn't necessarily mean it's a primitive way of doing it, although it kind of is. But a primitive, you may have seen the primitives menu in Lychee. If you use Lychee Slicer, a primitive is just a predefined shape. And so far we've been working with primitives. In the next course, we will look at doing sketch-driven designs. But for now, for just kind of demonstrating the navigating and everything else, the primitives work just fine. I don't love primitives just because they're not always as tightly controlled or constrained as creating an object from a sketch. And again, we're going to run out of time before we see that tonight, so that'll be in the next one where we'll start looking at sketches. But you know, the question would come up maybe, okay, why do you need a tool to cut or join or intersect after the fact if you can do that when you're creating the object? And I would say here is why. If we created we created a donut, but we want to cut a really complex shape out of our box here. We created the donut, we copied the donut. Now, if we turn on our diagonal cutting plane, yeah, this will be good. Now, let's say that complex shape that we want to cut out of our box is sort of 2 half donuts cut out of the box. What I can do is I can use my combine tool. Now, this is a little bit of a tricky name because it's not only for combining. This is where we're going to find those same operations: cut, join, intersect. The technical term for these would be a Boolean operation. So if you're familiar with like the idea of Boolean logic, there's and, or, etc. That's what we're doing here with the combine tool. So first thing I'll do, I'll pull up the combine tool, and I'm going to use a join operation first, and I'm just going to join these 2 donuts together. And you see we have 3 bodies in our browser right now. But once I hit OK, now we only have 2 bodies because those 2 donuts, I joined those into one. Now, if I take this double donut shape here, I select it, and I use split body. I have body to split selected. But now it knows now it wants to know what tool to use to split this body. I'm gonna click here, select splitting tools, and I'm gonna select that angular plane that I made, hit OK. Now we have 3 bodies here again because it split that body into 2 bodies along that plane. If you think of that plane as being like a table saw blade, it cut that body into 2 bodies. And so now I'll turn off the visibility of one of those bodies. And now we have this really sort of funky complex shape. And now if I go back and use my combine tool again, my target body, since I want to cut this complex shape out of the box, my target is the box. That's the body that we're going to do the operation on. And then my tool body is going to be this sort of funky, now it's like 2 pieces of macaroni stuck together. But I'm going to first switch over to, well, I'll just show you all 3 options, I guess. So If we use a join operation, then it's just going to combine the box and the macaronis into one body. If we use a cutting operation, it's going to cut away the macaroni from the box, and that gives us a funky, complicated shape there. If I go back down to my timeline and I double click on the combine tool, let's say I change it to intersect, then it gives me only the area where the box and the macaroni intersected or occupied the same space. So that's another way to do the cutting, joining, and intersecting operations. And I'm not going to go any further in depth on this now, but we will definitely over future courses look at times where we might want to keep the tools. So where I might want to cut this double macaroni shape out of the box, but not eliminate the double macaroni shape and still have it around. So if I wanted, we use this a lot for like, if I'm creating two parts that mate to one another and I want to use one of the parts to cut away the mating surface on the other, but I still want to keep the other part because it's an actual part that I'm going to print, that's when we might use the keep tools option. And so I mentioned the primitives. That's certainly one way that you can start a design. It's just definitely not my preferred way, and we'll kind of look more at why in the next course. And so the next course, we're really going to hit this create menu pretty hard. So the idea that I have for the next course here coming up on the second Monday of August, it is August 12th, Monday, August 12th. I was planning on walking you guys through how to design a drop axle like you might see on a Model A hot rod. We'll do a drop axle from start to finish, and it will kind of cover basically all of these tools. So to give you a real good hands-on look at what each of these tools does and how to use them, but also how to like start from a sketch and things like that. So
okay.
That's where I'm going to pause this one, but I want to check in, see if anybody has any questions on what we covered so far tonight.
That's pretty cool. That's it's like an advanced thing from if you know some basics. It kind of like elaborates on all of it. It's different terminology from what I can see on some of it.
Yeah,
but it's actually the same thing.
Yeah. My goal is to create, as we go along here, is to create sort of a glossary and create a page on the Scale Speed Academy, a tab on the Scale Speed Academy page where there's a glossary of terms, like a searchable glossary of terms.
Well, that'd be cool.
So my plan is, and fingers crossed it works, but my plan is to take the video, use some software tools to copy or to transcribe the audio out of it, transcribe my narration out of it, and then run that transcription through ChatGPT and help, have ChatGPT kind of help me pull out the terms and start creating this glossary. So,
Okay.
yeah,
Sort of like an index, more or less, an index.
exactly.
A dictionary of terms and stuff.
Yeah.
That's cool.
Yeah.
Because when I can see, I was a little late getting here tonight, but had a little trouble getting on the site for some reason. I don't know why, but from what I can see, a lot of it is relatively the same. It just terminology and ways of doing it. In other words, like when you were spinning the thing around and whatnot, some you just hold the key down and go, and some of them you got to rotate the. So I can see where that's about the most confusing part right there.
Sure. And just to clarify, I should I should give a clarification on that. When we are using the navigation tools, either from down here or by like holding down shift and holding down our mouse scroll wheel, when we're using these navigation tools, we are essentially changing where we are located, not where the object is located, right? So if we keep an eye on our origin point here, this is the 0, 0, 0 point, the 0 point of all of our axes. This is like the center of our universe. And so when we use the navigation tools, we're moving where we are in relation to the object. We're not moving the object.
It's like we're walking around the thing.
Exactly. Yep. We're walking around it, or we're flying around it in a helicopter, or what have you. We're changing where we are when
The
we
object stays still.
Whereas conversely, if we move the object,
That's a different story.
that's a different story. We're staying in the same place, but we're moving the object. And so I'm going to open back up our data panel here. I'm going to create a new folder. This is going to be course 1, 7/22/24. Maybe. Let's try it again. Maybe it didn't like the, it probably didn't like the slashes. It's the same as, like, you can't use slashes in Windows folder names. You can't use them as well. So we'll do this again. Course 1 dash intro dash 7/22/24. There we go. And so I'm going to move this object. I'm going to leave this file, even though it was just kind of a thing we were messing around in. I'm going to leave this here, so once I add you into the project, if you want to come back in and open this up and play around with it and, you know, scroll through the timeline and make changes to things, by all means, you can do that.
I like that timeline thing. That makes it a lot easier.
Oh,
because
yeah.
If you make a mistake or you want to go back and correct something, you don't have to redo the whole thing necessarily. You can just do it, do what you have to do.
Yep, exactly.
Because a lot of times I notice I've done things on other, and if I've made a mistake, I can't go back. I've got to get rid of it and go all the way back and do it all over again.
Yeah. That feature alone is one of my favorite things about Fusion, and I think one of the best things about it is there's so much potential for saving time, because the reality is we're going to design plenty of things as we go along where, you know, you maybe print it and say, oh shoot, that doesn't work, it's too big. No big deal. You come in and you change what needs to be changed, and, you know, there's no drama. So I'm going to move our test1 file into our course intro. I can do this in a couple ways. I can right click it and then come down to move, and then it pops this up, and then I could just select the course 1 folder and hit move, or I can also just, why are you turning me into a liar here? So there are two ways to do it. We can right click and hit move. And this is going to be the simplest way. The other way would be to open up the web browser based thing. But for moving single files, there's no reason to do that. It does come in handy if you need to move single folder or like entire folders or multiple items. But for this, we'll just right click on test1, hit move, come up here, select the folder we want to move it to and click move. And then boom, it's populated into that folder.
There we go.
I'm going to get rid of those. And thank you guys all for coming. If you have any questions in the interim, by all means, feel free to shoot me a message or an email. I'm happy to answer those. And hope I see all of you here in a few weeks.